So electric field in the plane electromagnetic wave Ez is this. Then expression corresponding to the magnetic field will be what? First thing you need to take care, if you are taking Z electric field in the Z axis, then your uh, electric field will be either in the Y axis or X axis. It cannot be Z, right? Because both are perpendicular to each other. Any doubt, guys? Next, if you are taking cos, because you know your C is equal to E naught by B naught, correct? So if you want to calculate B naught, an electric field is given E naught by C. Yes or no? And all these are notes are the last year notes. You can compare same thing. Ki we already discussed this. C is equal to E naught by B naught. Direct equation. We wrote this electric field and magnetic field are perpendicular to each other. Okay. So what will be your B naught value? B naught value, whatever is the E naught by C. E naught is 60 because Ez is equal to E naught cos. You know, na, E is equal to E naught cos theta, something like that. So what is C value? 3 into 10 raised to power 8. This will be 20. 20 into 10 raised to power minus 8 or 2 into 10 raised to power minus 7. So you can eliminate this. Correct. Now you have to identify which direction it will be in. Electric field and magnetic field are present in the same phase. Did I write? It was there. They are present in same phase, same sign, same phase. It will be same phase. So when they are present in same phase, everything else is same. 5x plus 1.5 10 raised to power 9, everything is same. You need to know whether it will be in the x axis or y axis. Correct? So how will you identify in this case? From the plane, which plane are you taking? Electric field in a plane of the electromagnetic wave. If you take Ez, here you have x. What is the meaning of x? It is propagating in x-axis. Do you remember same thing we did in the waves also? Ki y is equal to a sine kx minus omega t. So what was the meaning of x? It was propagating in x-axis. Correct. So imagine ki you have your electric field in z-axis. Wave is propagate in x-axis. What will be the direction of the magnetic field? Y. Understood, guys? Any doubt? The question was not difficult, it was pure theoretical because you don't need to calculate anything. Example, if I do the same question again, then I know ki if I have this electric field and I want to calculate a magnetic field, then this is the formula. So you can calculate, correct? Second, if you have z axis, then magnetic field will be perpendicular to this y or x. So z is not possible. If you have cos in the question, your answer should have cos then. Now you have to identify which axis, x-axis or y-axis, because you don't need to calculate anything else. Number you don't need. You need to check direction. If this is z-axis and this is x-axis, then you know your magnetic field will be in the y-axis. Yes or no, guys? Correct? Because we discussed this, I showed you diagram. I'll check your diagram. First statement: electric field and magnetic field are perpendicular to each other, and they are perpendicular to the direction of the propagation of wave. In this particular question, your electric field is in z-axis, perpendicular to this your propagation of wave in x-axis. What will be the propagation of magnetic field? Y-axis. Yes or no?
Yes,
Any
sir.
doubts, Chandana? Chandana, any doubt?
No, sir.
Sarah?
No, sir.
Yeah. So that is the thing. If you even go through the explanation of this, still you won't understand. You will understand कि it will be 10 raised to power minus 7. But why y-axis? Even if you say कि I mentioned this, कि plane are perpendicular to each other. Even x-axis is perpendicular, right? Even x-axis is perpendicular. So you have to correlate. If wave is propagating in x-axis and your electric field in z-axis, then this will be in the y-axis. This is important because everything was same. Now, are you feeling now, कि sir, last year question, no doubt, 5-10 questions were really difficult, but not all, right?
Yes, sir.
Next, electromagnetic radiation, Sarah, have the smallest wavelength is Sarah.
So gamma rays.
Gamma rays, yes, visible, infrared, micro, and radio. So gamma is minimum wavelength, maximum frequency. Then Chandana, ratio of the relative permeability and relative permeability and relative permittivity is 1:4. Calculate the ratio of the magnitude of electric field and magnetic field intensity in the propagation of the wave. Yes, you have this value. Based on this, you have to calculate what is the ratio of the electric field and magnetic field intensity. This is the relative permeability. So nu R and yes, Sana,
Yes, sir.
this is 120 pi.
So 60 pi.
60 pi. Yes, it will be. So here you have relative permittivity, and you are comparing the ratio of the electric field divided by the magnetic field. It's like that. And electric field divided by magnetic field is equal to the speed of light. Correct? This is equal to the speed of light. But if uh, you compare the relative, what do you say, relative condition. So you know nu r will be equal to nu by nu naught. Same epsilon r will be equal to epsilon epsilon by epsilon naught. Correct? For a given medium, your nu value will be equal to nu r and nu naught, and your epsilon value will be epsilon r and epsilon naught. Any doubt? Correct? Epsilon r and epsilon naught. So then you can calculate their ratio. Sarah, any doubt you have issue with this question?
No, sir.
Hmm. Then Sarah, tell me example. It is given uh, this magnetic field intensity, not magnetic field. So what is the relation of H with the magnetic field? Is this correct? This is given magnetic field intensity, not magnetic field. Magnetic field intensity is magnetic field divided by nu. So uh, that's why this is not is equal to C. E by B is equal to C. That to E naught and V. So if you take E by H, can you also write, Sarah, H will be equal to B by nu naught? Nu, because for a given medium. What is E by B? Your velocity into nu. And what is the velocity formula? 1 by nu epsilon. How do we know? Look at this. I think I wrote somewhere, maybe before, for a given medium. No, I guess I wrote for a given medium. Next we'll see. Yes, this I wrote. If you want to calculate velocity for given medium other than the free space, then it will be E by B. In free space, it will be C. Now, in this question, we are calculating for a given medium. That's why your velocity will be equal to E by B. And E E by B is equal to your velocity, and velocity is also equal to Y, because your C is equal to 1 by nu naught epsilon naught. So your velocity will be 1 by nu and epsilon, not nu naught. Okay. Then put the value and get answer. Sarah, any doubt?
No, sir.
Chandana, any doubt? You solved question already. Sarah, next question. Property not electromagnetic wave travel in the free space. See, they are asking property. Transverse wave, EM wave or transverse wave. Is this correct? Did I mention this transverse wave word? Energy density. Okay, then I will add one more line. हाँ हाँ हैं ये बुंडा था तो मैंने वो कर दिया था दो दिया था दो दिया था पानी वाला सिंपल पानी के बाथरूम में हाँ फिर माँ ही बुगा मावेगी तो सूख जाएगा भैया अब लो दिन हो गई यूरे पड़ा था और इसमें कुछ की थी यू था उसके अलावा उसमें कुछ डंगा से डरा था हम्म पीऊंगा एक मिनट सो guys, this EM wave is transverse wave. I read this in my notes. How I forget. Okay, so this is the transverse wave. How do we know? From the wave scepter, we have two type of wave: longitudinal and transverse. Example: you have longitudinal wave. Example in case of sound, rarefaction and compression. Correct. There you have longitudinal wave in rarefaction and compression. Example: sound wave. Sound wave or longitudinal wave. But if you take the transverse wave, it move up and down. That is transverse wave. How? Example: up, down, up, down. This is the transverse wave. This happen in case of light or EM wave. Any doubt, guys? This is how we'll revise the. We'll keep adding the notes. So, Sarah, first statement is correct.
Yes, sir.
Second, energy density of electric field is equal to energy density of the magnetic field. Is this correct?
Yes, sir.
Yes, because we already discussed energy density, electric field, magnetic field, it will be equal. So here we took total, but you can take this also. Both are equal as well. Why? Because their energy is also same. Energy density is energy per unit volume. Because energy is same, energy density will be same. So U E will be equal to U B. Done. So second is also correct. Third, Sarah, travel with the speed 1 by nu naught epsilon.
Yes,
In
sir.
free space, your c is equal to 1 by epsilon naught nu naught under root. For any other velocity, it will be nu and epsilon under root, right?
Yes, sir.
Hmm. Do we have in our notes?
Yes, sir.
I think I wrote it somewhere, but I'm not able to get this equation in the form of nu naught epsilon naught. See here, c is equal to nu naught epsilon naught and v is equal to. And that's why I was asking, thinking I wrote it somewhere. So they originate from the charge moving in the uniform speed. Is this correct?
Mm, no, sir.
Then what is the right answer?
Need not be uniform speed rate.
Then
And
accelerated charge. And in accelerated charge, you don't have uniform speed. So we will add produced due to accelerated charge. Correct? It means charge is moving with a different speed, not uniform speed. Not uniform speed. Then Chandana, in a plane of electromagnetic wave traveling the free space, electric field components oscillate sinusoidally sine at this frequency and this amplitude. So your E naught is 48. Your frequency is equal to 2 into 10 raised to power 10 hertz. Then amplitude of the oscillating magnetic field. You know T will be equal to E naught by B naught. Yes, Chandana, calculate.
Yes.
Was it easy? Direct formula based. C is equal to E naught by B naught. Chandana done? See,
Yes.
C is equal to E naught by B naught. The formula based question. And you will feel we don't need the frequency. Sir, an AC source is connected to the capacitor due to decrease in its operating frequency. If frequency decrease, what will happen? You have to correlate with the AC. In AC, you know capacitive reactance will be equal to 1 by C omega, 1 by C 2 pi nu. So can you say XC inversely proportional to the nu? And if your frequency decrease, then your resistance will increase. If resistance increase, current will decrease.
Yes, sir.
Make sense?
Yes, sir.
Now understood, Sarah, again why uh, it is important to do other chapter to correlate with this chapter.
Yes, sir.
That's the reason, Chandana, ki people face issue in the physics. Reason when they do chemistry or biology, they are reading particular chapter, they can easily solve question because direct related question. But if you see the physics, you can never solve question if you don't know full syllabus because you never know how question will arise from the other topic. So we'll mention this point also. If we introduce capacitor, because in displacement current you have this capacitor. So if we introduce capacitor, then current, we are talking about the displacement current will inversely depend upon the XC. Current will inversely depend upon the resistance. So more resistance, less current. And we know XC is equal to 1 by C omega. Correct? It is 1 by C omega. So can we say it will directly proportional to like this? And you know omega is equal to 2 pi nu frequency. So it is directly depend upon the capacitance and new frequency. Now it depends what question is asked and how you can correlate in this particular topic also. This here you have capacitor, and when you have capacitor, again you can write here in your capacitor, in capacitor your xc is equal to 1 by c omega or 2 pi nu. Okay, 2 pi nu. If you know this, it is equal to 2 pi nu, what will happen? Xc is inversely proportional to the nu, and you know current displacement current will inversely proportional to the xc. Now it depends what kind of question will be asked. You can solve. They can ask कि if you increase capacitance, what will be the impact on the displacement current? Directly proportional. Correct. Through this, we can also calculate कि your displacement current directly depend upon the capacitance, directly depend upon the nu, right? So if capacitance increase, current will increase. If frequency increase, current will increase. Make sense, guys? Anybody have doubt?
No, sir.
If you don't, then solve next question. Chandana. Minimum wavelength of X-ray produced by an electron accelerated through potential difference V will directly proportional to the. When wavelength is minimum, then your energy will be maximum. And when electron is moving, remember, when it is moving, that what will happen? Your kinetic energy or energy will convert into the potential energy. Make sense? Ultimately, potential energy. What is overall energy in your uh, question? E is equal to h nu, and potential energy is charge into potential. Make sense, guys? E is equal to h nu, and your potential energy is equal to q into v. This is equal to hc by lambda minimum. Here, what is the relation? That's the reason why people hesitate in physics, because they believe कि when we are doing the topic of a particular chapter, we will get question only from that topic. But in reality, you can get anything, and everything is related. Sarah, were you taught ki how to correlate every chapter like in this way?
No, sir.
And that's the main reason why you were facing issue in the NEET physics question.
Yes, sir.
Chandana, same pinch,
Sir?
same pinch. Like you were facing same issue that you were not able to correlate multiple chapter together in
Yes.
physics, and that's why you face issue in physics.
Yes, sir.
And that's the reason. See, we can do chapter wise also, like chapter wise question after finishing the portion. But I will do full syllabus. Why? Because it is about correlating the full syllabus, not chapter wise. We don't have content chapter wise. We have content full syllabus. That's why examiner can ask any relatable topic. And this will be possible when you are in constantly touch with the full syllabus. Constantly. That's why I believe every coaching institute 3 months in advance should solve only full syllabus paper. Even students are not confident. Why? Because it's not about how much marks student get, but it's about how student get confidence with the time ki okay, now I can do. Understood, guys?
Yes, sir.
Huh.
Yes.
So that's why I will consider this copy. We will add in our notes. Minimum wavelength of X-ray produced by an electron accelerated to a potential difference is proportional to. Yes, proportional to.
Sir, is it okay if I leave now?
What happened, Sarah?
Sir, I'll have to go to college.
I am doing this last content only because we are almost done.
Yes.
Huh. So, if you solve this question, then you have to understand this minimum wavelength and electron, and it is accelerated. Your speed is changing. So, you cannot use velocity part in this case because it is accelerated, and then you have potential difference. If you correlate with this, here your energy, kinetic energy, will convert into the potential energy, and energy when it is moving, then E will be equal to h nu or hc by lambda, correct? And in potential energy electrostatic, U is equal to charge into potential, and when it will stop for fraction of second, then both will be equal. Hc by lambda will be equal to q into v. So you can say h is constant, c is constant, electron is constant. That's why your minimum, this will be directly proportional to 1 by v. But why this is important? You will think about dual nature of matter also in this. You will think about dual nature of matter also. And in dual nature of matter, you will think about under root V. Key, in dual nature of matter, electron wavelength is equal to h upon p. Here h upon uh, p is equal to 2 me, energy or kinetic energy, and E is equal to voltage. Correct this? And based on this, you will consider ki, sir, this can also be this, right? And interesting thing is, you had this option also. Tell me how, Chandana, you were thinking about dual nature of matter?
Yes, sir.
Then, okay, Sarah, were you thinking about dual nature of matter in this question?
Yes, sir.
If you were thinking about the dual nature of matter, because I had same thought process in the beginning, yeah, dual nature of matter. But main word is accelerated. If you have fixed mass, then there is no issue if there is a like uniform velocity, because in uniform velocity, your um it will inversely depend upon the mass only. But here you cannot do like this. And reason, because of the accelerated charge, not uniform, accelerated charge. And when it is accelerating, your energy, kinetic energy will be equal to the potential energy, because total mechanical energy remains same. Total mechanical energy remain same. This is energy this, and this is the potential energy. Okay, not this. Not this. What would you say, guys, about this chapter? Is this easy? Though you are getting question from the different topic, that is the different thing. But when you are asked only from this chapter, is it really easy and straightforward?